So the last part here are the type 1 and type 2 errors. When we did confidence intervals, you constructed an interval and let's say the confidence level was 95%. Remember, that means only 95% of all possible intervals of the same sample size we're going to actually capture the true parameter value. So that means there's the 5% that do not. So just like with confidence level intervals, we may or may not have the right conclusion. So there are two errors that could happen here. A type 1 error occurs when the test rejects the claim, but the claim is actually true. So this is when the p-value is less than alpha, but really something else happened. We should not have rejected it. Type 2 error occurs if we fail to reject, type 2, fail to reject, when we should have rejected. Okay, so here's a good summary chart. We have the truth about the population, the claim is true or the alternative is true, and a conclusion based on the sample, we reject the claim or we fail to reject the claim. So if we reject the null hypothesis, but the null hypothesis was true, that's your type 1 error. Reject the null hypothesis and the alternative is true, that's correct. We should have rejected. If we fail to reject the claim and the claim is true, that's correct. We got a large p-value. It's supposed to happen, so the claim is true. If we fail to reject the null hypothesis, but the alternative is actually true, that's your type 2 error. So let's look at actual context here. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of 500 potatoes from the shipment. The producer will then perform a test at the alpha's 0.05 significance level of, and we have all our hypotheses. The null hypothesis is that the true proportion is equal to 0.08. The alternative is that it's greater than 0.08, where the P is the true proportion of potatoes with blemishes in a given truckload. So describe a type 1 and a type 2 error in this setting, and then what are the possible consequences? So type 1 error, that's when we reject the null hypothesis when we shouldn't. So the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, when the true proportion is really 8%. So the consequence here is, well, we found that more than 8% of them have blemishes, so we're going to send the truckload away. But they were acceptable because it wasn't more than 8%. So you're wasting time. The supplier now is out money because they were going to sell the potatoes to someone, but now they're being sent away, so they're having to do something else with it. A type 2 error is when we fail to reject the null hypothesis, when we did not find convincing evidence, but we should have. So the producer does not find evidence that more than 8% of the potatoes in the shipment have blemishes, but in reality, it is greater than 8%. So we're making potato chips with potatoes that have blemishes on them, which could cause customers to stop buying the chips. Remember, grabbing a bag of potato chips, you're looking for that nice golden color on the chip, but then you get all those dark brown, they looked over fried type of potatoes. Or when they're cutting the potatoes themselves to then fry them, they have to scoop out a ton of them, so they're not being able to produce as many potato chips. So the most common significance levels that we talked about before were 5%, 1%, and 10%. So which one of these is best? Well, it depends on whether a type 1 error or a type 2 error is more serious. So a company will want to think about, okay, what could possibly go wrong with my testing? Which error is worse? Which one should I be more cautious of? So a type 1 error, the probability of a type 1 error is actually equal to our significance level. So if we use 5%, that's the probability of a type 1 error. We use 10%. That's the probability of a type 1 error. So in this potato situation, is it worse to send away a truckload that you shouldn't or use a truckload that you should have sent away? So type 1 is we sent it away, but we shouldn't have. So at the 5% level, that, or 0.05 significance level, it's a 5% chance that that's what's going to happen. So we can decrease the probability of making a type 1 error by using a smaller significance level, since those are the same value. The probability of a type 1 is equal to the value of the significance level. But there's a trade-off between the probability of a type 1 error and probability of type 2. As one increases, the other decreases. So if we make it more difficult to reject the claim by decreasing alpha, we increase the probability that we will not find convincing evidence.